Good evening, Tiger Physics students. Here's a quick guide for how to write a formal lab report for physics. First of all, the title. It's worth 2 points. Write a reveal title, format it like a title. Do not name your lab lab. It's worse than naming your dog dog. If this is the motion sensor lab, call it the motion sensor lab. If it's about finding coefficients of friction, tell yourself so. Do not name your title title. Format it, center it like a real title. Unlike anatomy and physiology, I do not actually give extra credit for clever titles with cute puns, but they certainly put me in a good mood while I'm grading. For your purpose, which comes next, try to phrase the purpose of the lab in your own words. Why? This serves as a fact check for your conclusion. If your conclusion doesn't address your purpose, you're probably missing a sentence or two. If your conclusion clearly states what your purpose sets out to find, you're probably in good shape. Make sure your lab is legible and organized. Make sure everything that's handwritten can be read. Don't use floating numbers and don't use incomplete ideas. You may write bullet points. You need not use complete sentences, but you have to explain what it is. If you're trying to define mu, explain what it means, not just what the formula says. If you've got a true-false question, state what you think is true or false. Put the sections of the lab in order. Order matters. Why? Because you may not have data after your conclusion. Data first, conclusion afterward. See the current state of modern politics as a counterexample of what not to do. You do not have to include the question, just the answer, as long as you write out the answer clearly with words like velocity and force and static equilibrium, putting in all the physics you need. When you're putting diagrams and charts in, hand draw them neatly and don't waste too much space. If you're taking pictures and inserting them into your lab, put them next to your text as opposed to a big collection in the beginning or the end. If you have to put all your pictures at the end, say, see figure 1 on page 4 as a citation to make sure that everything comes in the correct order. Don't make a mess. Don't backdate a revised hypothesis. If you had a guess and your guess was mistaken, say so in the conclusion. That's not a bad thing. That's what scientists call results. Don't skip steps, and don't leave characters that make it look like your cat walked across your keyboard. This is 2022. Insert symbol just as well in Google Docs and Microsoft Word. Find the one you want and use subscripts and superscripts to make your labels look nice. For the finding friction lab, where you're measuring the coefficient of friction, after the title that you write yourself and the purpose that you write yourself, make sure you have the correct answers to the preliminary questions. You can do these in short paragraphs or bullet points. The answers can be as short as you please as long as they are complete. Number 1, you can check on Canvas what is the meaning of what you're finding. Number 2 cites the first formula where you ever found the coefficient of friction. Go to that formula and cite what else was in the formula. I will bet you anything it wasn't sine theta or cosine theta. If you're using sine and cosine and tangent, you are measuring these forces indirectly. If you used a scale of any kind, something with a slider or a digital readout, then you measured these forces directly. Specifically, you used the scale to measure F pull, because you pulled on it and the scale moved. Use 3 through 5 to set up your procedure. Most of your procedure will be pictures and free body diagrams. Draw a sketch of what you did, either by hand in your notebook or with your mouse, Or if you're really procrastinating on starting on that A push, you can go search up pictures of your exact shoes and try to make a little ramp and try to recreate a photo if you're going to be a patent attorney and are trying to study how Photoshop can be used to recreate the real world. Put labels on everything, including all the things you had to check while you were working in the lab, such as people with the scale who had to discover not to hold it at an angle, and people who were watching for a deviation from static equilibrium. Put all that here. The actual numbers that you measure go here in the data section as opposed to the procedure. If you wrote them down in class in the same place, that's fine, but you can see calculations and data, and you can say as above to make it clear that you know your data ended up in the procedure section. Most everybody has one data point, two at the very most. You won't need a table, but make sure everything is labeled on your diagram. Show your work with your trigonometry and solve as far as mu equals. Remember what we said in class. Your first step is to make a free body diagram. Cover it with labels. Put on every formula that's relevant. Then check for equilibrium. If it is or it isn't, make sure you have it labeled. Find the net force in letters and words, no numbers. Once you have that formula, set it equal to something useful. What is the net force equal to if you are in equilibrium? What's the net force equal to if you're not in equilibrium? Which one is it? That done, once you've set that equal to something, you will have, just like on your safe angle problem, enough information to solve for something and eventually for the coefficient of static friction. Those of you who used a pull scale, that scale measured F pull. You ought to be able to find the normal force based on one other measurement you took. Those who built ramps, you should have a tidy little formula for mu. It ought to be a pretty little decimal of the kind you found in class. Once you have that decimal, you are done and ready to conclude. Consider your procedure and explain honestly what could have gone wrong. If they don't hear it from you, they'll hear it from the tabloids. Don't just say, oh, it was human error. Specify. If you used a meter stick, seriously, what could have gone wrong? What could have gone wrong with your tile? What could have gone wrong with your scale? As we said in class, the way you tell whether data is reliable is not the purely subjective, I've got a bad feeling about this lab, Obi-Wan Kenobi style. You can tell whether this data is reliable by comparing it to data taken by other scientists who had access to more time and better equipment. If your data looks like it belongs on the notes that we took in class about coefficient of friction and the big data set from the engineer's edge, your data is pretty reliable. If it looks like your shoes are made of sandpaper walking on duct tape sticky side up, that data is not reliable and your sources of error were probably pretty big, which will tell you what to do differently next time. The formal lab report doesn't have to be 4 pages long as all of this is here in order and neatly labeled. Good luck, everybody.